Welcome YouTubers to another episode in my Grammar Heroes series. In today's video, I'm going to show you the solutions to the arithmetic reasoning subtest of the third practice test on my website. In case you missed it, I recently created a website called mastertheasvab.com. There you can take 3 practice tests as well as estimate your AFQT score. That said, let's go ahead and get started with today's video. Question 1 says, Down syndrome occurs in about 1 in 250 children when the mothers are in their 20s. What percent of all children born to mothers in their 20s are likely to have Down syndrome? So we should recognize right away that to convert 1 out of 250 into percent, the first thing we have to do is represent this as a fraction. More specifically, we're going to write it as 1 over 250. Now, there are 2 ways to go about doing this. You can regard this as long division, namely 1 divided by 250, or to make this a fraction that you can do mentally, you can put this denominator, you can make this denominator 1,000 while multiplying 250 by 4. And what you do to the denominator, you would have to do to the numerator. So 1 times 4 would be 4. 250 times 4 would be 1,000. Now in this case, we should be able to see that 4 divided by 1,000 is going to be 0.004. Again, this is the tens place, hundreds place, thousands place. 4 out of 1,000 is the equivalent of 0.004 with the 4 in the thousands place. Now this problem's a little tricky because we converted the fraction to a decimal, but we haven't converted the decimal to a percent yet. So if you selected this answer choice, you would have gotten it wrong. To convert this decimal to a percent, we have to multiply 0.004 by 100. And instead of working that out, we have to recognize that whenever we multiply something by 10, 100, or 1,000, it just shifts the decimal place either right or left according to the number of zeros in that number. So in this case, 100 has 2 zeros, so I'm simply going to shift this 0.004 2 times to the right, so I can see that this is going to be 0.4%. which is right there. Again, this is a pretty challenging problem. In all honesty, all the problems in this third practice test are fairly challenging. If you're going to score somewhere between 60 and 99 for your AFQT score, you're going to see a lot of problems like this. Okay? Let's move on to the next problem. Question 2 says it costs 75 cents to make color copies at a copy center. At this price, how many copies can be purchased with $45? So to set this problem up, we're going to do 45 divided by 0.75. Again, that's how many times does 75 cents go into $45? And as is the case with all fractions, you can regard this as division. 45 divided by 0.75, so that'll look like this. Now, we're not quite ready to do the long division. I have a video up on my YouTube channel that's devoted to dealing with decimals. In that video, I mentioned that you can divide, you can do division with decimals as long as the decimal's on the inside of the division bracket. In this case, it's on the outside of the division bracket, so I'm going to have to shift it 2 places to the right. What I do outside the division bracket, I have to do inside, so the decimal's here, 1, 2. So in reality, we're going to be working out this problem. Let's find good space for it. We're going to do 75 we're going to do 4,500 divided by 75. Okay? Now, if you take out a look at our answer choices, this will help us solve this division problem without doing too much work. We know that 75 is pretty close to $1. If each copy was $1, we would say 45 divided by 1 is $45. In other words, you can get 45 copies if you need 45 copies for $1 each. So we know this isn't the correct answer choice. If we're estimating by shifting this 25 cents up to $1 that you can make 45 copies here, 6,600 are unreasonable estimates. So just by using logic to eliminate answer choices, you would be able to select 60, and instead of doing finding what number goes into 4,500, I would just take 75, multiply it by 60 to confirm that is the case. 5 times 0 is 0. 0 times 7 is 0. Add a 0 since we're starting this number. 5 times 6 is 30, so we put a 0 there and carry the 3. 7 times 6 is 42, plus 3 is 45. Let's add 0 plus 0 is 0. 0 plus 0 is 0. 5 plus nothing is 5. 4 plus nothing is 4. So we can see 75 times 60 will get us 4,500 with no remainder. Okay? Again, you have to be able to use your knowledge of math to help you guide yourself to the right answer without doing an incredible amount of work. Alright, number 3. Out of 100 shoppers polled, 60 said they buy fresh produce every week. How many shoppers out of 45,000 could be expected to buy fresh produce every week? Okay, so we're told 60 out of 100 polled said they buy fresh produce. This is the equivalent of 0.6. To solve this problem, we're going to extrapolate this 0.6 to 45,000. More specifically, we're going to take 45,000, multiply it by 0.6. When we're doing multiplication with decimals, we have to add this, move this decimal to the right once, and add it back in once we're done. So in reality, we're doing 45,000 times 6, albeit with one decimal to add back into the left at the end. 6 times 0 is 0. 6 times 0 is 0. 6 times 0 is 0. 6 times 5 is 30. Carry the 3. 4 times 6 is 24, plus 3 is 27. Add our one decimal back in. We can see that this is going to be 27,000, which is that answer choice. Alright, number 4, a piece of ribbon 12 feet 6 inches long was divided into 5 equal parts. How long was each part? So we got a piece of ribbon that's 12 feet 6 inches long. We're dividing it into 5 equal parts. Now at this point you're probably saying, how do I do this since it's feet and inches? The trick is to convert everything to inches and then convert it back to feet and inches if needed. Again, there are 12 inches in every foot. So we should know that 12 feet is the same as 12 times 12 inches, which is 144 inches. And then we have this 6 inches hanging out there. So this problem instead is going to be 144 plus 6, which is 150 inches divided by 5. Again, we got to get comfortable doing mental math. Instead of regarding this as division, namely 150 divided by 5, We're going to do that, but we're going to do it mentally. We're going to say to ourselves, 5 goes into 15 3 times with an extra 0. So 150 divided by 5 is 30. So in other words, each piece of ribbon is going to be 30 inches long. We do not see that as an answer choice. As we take a look at our answers, we can see that they're in feet and inches. So again, we have to know there are 12 inches per foot. Again, 12, 24, 36. This is 1 foot. This is 2 feet. This is 3 feet. So we can see 30 is between 24 and 36. So this is going to be 2 feet, 6 inches, which is right there. Okay, question 5 says, the temperature outside is 68 degrees Fahrenheit. What is the temperature in degrees Celsius? And we're provided with the formula to convert between Fahrenheit and Celsius, namely Celsius equals 5/9 times Fahrenheit minus 32. Here's the degrees in Fahrenheit, so we're going to go ahead and plug it into the formula. Again, the formula is Celsius equals 5/9 Fahrenheit minus 32. We're told that the degrees in Fahrenheit is 68 minus 32. Again, I just took what was given and plugged it in for Fahrenheit. 68 minus 32 is 8 minus 2 is 6. 6 minus 3 is 3. So we're given this becomes 5/9 times 36. Now we're multiplying a fraction to a whole number. In order to do that, we have to convert this whole number into a fraction. To make any whole number a fraction, you put it over 1. So to make 5 a fraction, you can write it as 5 over 1. To make 10 a fraction, you can put it as 10 over 1. Similarly, to make 36 a fraction, you can put it as 36 over 1. So in other words, 5/9 times 36 is equivalent to 5/9 times 36 over 1. And when you multiply fractions, you multiply straight across. But 5 times 36 is a big number, and instead of doing that, I'm actually going to reduce this a little bit before I multiply. I know 9 goes into 9 one time, and I know 9 goes into 36 4 times. So this, when I reduce it, is the same as 5 over 1 times 4 over 1, which is the same as 5 times 4, which is the same as 20. Okay? Grab my pen again. 6. Tallahassee is 80 miles west and 60 miles north of Bougainvillea. How long is a direct route from Tallahassee to Bougainvillea? So, in this case, we're going to have to do a sketch to help ourselves out. Whenever I get directions involving north, south, east, and west, I like to make a little compass in case I mess these up. We're told that we're starting at Bougainvillea, so let's say that's right here. It's 80 miles west. West is this way. And it's 60 miles north, which is this way. So right here, according to the instructions that were given, is Tallahassee. The question is, how long is a direct route between the two cities? Direct route would be that route. And as you can see, they gave us directions that formed a right triangle. And again, this is 60 miles north. So in light of the fact that they gave us directions that formed a right triangle, we can actually use the Pythagorean theorem to find this side, which I'm going to call C. Specifically, the Pythagorean theorem is this: a squared plus b squared equals c squared, where c is the hypotenuse and a and b are legs of the triangle. Of course, the hypotenuse is always directly across from the right angle of the triangle, and the legs are interchangeable. So you can let 60 be a and 80 be b, or 80 be a and 60 be b. Okay, so let's go ahead and start plugging things in. I'm going to do 60 squared plus 80 squared equals c squared. Again, c is what we're trying to find, namely this hypotenuse. This math looks like it's going to be complicated because of these zeros. So I'm just going to kick these zeros off for now. At the very end of this problem, I'm going to add a zero back in. So this is going to be 6 squared plus 8 squared equals c squared, albeit with a 0 to add back in at the end. 6 squared is 36. 8 squared is 64 equals c squared. 36 plus 64 is 100. Again, that equals c squared. To get c by itself, we now have to take the square root of both sides. This crosses out the square root, so we're just left with c. The square root of 100 is 10. And again, I took a 0 away here to make the math easier. Now I'm going to add it back in right there, so we can see that this distance is going to be 100 miles, which is right there. Okay, number 7. Body mass index, BMI, is equal to weight in kilograms over height in meters squared. A man who weighs 80 kilograms has a BMI of 20. How tall is he? So they did not give you the formula per se. They wrote it out for you. In order to do this problem, you have to convert this to a formula, a mathematical formula that you can work with. So we're told BMI equals weight in kilograms, so kg, over height in meters squared. I'm just going to call that h squared. Okay? And we're actually given a few pieces of this equation, namely the BMI, which we can plug in there, and the weight, 80 kilograms, which we can plug in there. So let's go ahead and do that. 20, again, that's the BMI. The weight's 80 kilograms, and we do not know the height. That's what we're being asked to find. Now, at this point, you can solve this problem just by inspection of this equation. Because if you think about it, what 80 divided by what squared will get you 20? 80 divided by 2 squared would be this. And I'm just going to plug these in for the h in this equation and see which one works. So let's start with 2. 20 equals 80 divided by 2 squared. Again, we're trying to see if this equation works. So this is 20 equals 80. 2 squared is 4. 20 equals 80 divided by 4. 8 divided by 4 is 2 with extra 0. 20 equals 20. That's a true statement. So we know this 2 meters is the correct answer. If however you wanted to solve this one algebraically, let's go ahead and take a look at that. It's not as easy as you would think in light of the fact that there's an h squared on the bottom. So it's going to look like this. 20 equals 80 over h squared. Again, the goal is to solve for h, that is to get h by itself. So what I'm going to do is multiply both sides by 1 over 80. That gets rid of the 80 on this side. 1 over 80 times 20 is 20 over 80. And again, this crosses out, so we're left with 1 over h squared over here. Okay, I'm going to go ahead and reduce this by kicking off these zeros. This becomes 2 over 8 equals 1 over h squared. 2 divided by 8, we can reduce this by a common factor of 2. That is, we can divide the numerator and denominator by a common factor of 2. 2 divided by 2 is 1. 8 divided by 2 is 4, equals 1 over h squared. Now we can take the square root to get rid of this squared. And what we do to one side, we have to do to the other. This crosses out the square root. And the square root of 1 is just 1. Again, this square root crosses out this squared, so we're just left with h. The square root of 1 is 1, as I just said. Square root of 4 is 2. And again, we're not done yet because this h is on the bottom. Now I have to multiply both sides by h. This crosses out. This leaves me with h over 2 equals 1. Now I have to multiply both sides by 2 to get h by itself. This crosses out the 2. We're left with h equals 1 times 2, which is just 2. Okay? The algebraic way to solve this problem is much more work. If you can read this formula and solve it logically, that's the best way to do it. If I was taking the test, I would not worry about this. If I can stop right here, plug my answers in, and come up with the right one, that's where I'd leave this problem at. And again, as I mentioned in the beginning of this video, these are more challenging questions. None of these questions are really that easy. All of them require you to think. All of them require you to be able to manipulate the algebra of the problem. So if you're struggling with this video, chances are these questions are a little bit advanced for you. Okay? Number 8, James is 6 times as old as Jim. In 2 years, James will be twice as old as Jim is then. How old is James now? So, to keep my work organized, I'm going to break this down into James and Jim. This is how old they are now. This is how old they'll be in 2 years. Okay? We're told that James is 6 times as old as Jim. Is means that we're in the now. So if Jim is x years old, that means James is 6x years old. Again, he's 6 times as old as Jim. In 2 years, James will be twice as old as Jim. Okay? So if we add 2 years to both of their ages, it's x plus 2, 6x plus 2. But we're told that James is going to be twice as old as Jim. And again, Jim's right here, so we would have to multiply this by 2. Now we got to solve for x, and we got to figure out how to do it. What I'm going to do is, using this plus 2 years, I'm going to solve for x, and then that's going to tell me how old James and Jim are accordingly. So let's go ahead and do that. I have x times x plus 2 equals 6x plus 2. Oh, that's a 2 out there, not an x. Let me fix that real quick. 2 times x is 2x. 2 times 2 is 4. Again, I just took this 2 and distributed it to this x, and then distributed it to this 2, equals 6x plus 2. I'm going to subtract 2x because I'm trying to arrange the equation such that x is by itself. This leaves me with 4 equals 6x minus 2x is just 4x. Again, we have this plus 2 hanging out. Now, to work on getting x by itself more, I'm going to subtract 2 from both sides. 4 minus 2, of course, is 2. And on this side, I have 4x. Now I'm going to divide both sides by 4 to get x by itself finally. And we can see x is equal to 2 over 4, which is the same as 1/2. Okay? We want to know how old James is now. So if Jim is represented by x, and he's 1/2, and x is 1/2, that means James is 6 of 1/2, which is the same as 3. Okay? Get another tough problem. Another way to have solved this problem would have been to just check these problems according to the rules here. So you could have said, if James is 3 now, that means Jim is 3 divided by 6, which is 1/2. In 2 years, that would make James 5, and that would make Jim 2.5, and we can see that 2.5 is 2 times as big as 2.5, because 2.5 times 2 is 5. So you could have solved this one just using the numbers that were given, or you could have solved it algebraically. Either way, this is not a fun problem to deal with. Okay, number 9. During his first 5 months at college, a student's long-distance phone bills are $103.30, $71.60, $84, $45.10, and $50. What is his average total monthly phone bill for the long-distance calls? So we're asked to find the average of his phone bills. So that's going to look like this. Average equals the sum of all the phone bills over how many phone bills there are. And I always like to refer to it like this. Average equals some number. Again, sum of all the numbers over how many numbers there are. Average equals some number. So let's go ahead and plug that in. Let's go ahead and set it up and see what it looks like. So we have 103.30 plus 71.60 plus 84 plus 45.10 plus 50. Again, that's the sum of all the numbers. How many numbers are there? There's 1, 2, 3, 4, 5 numbers total. So as you can see, this is a fairly straightforward problem. What makes it difficult is that we have to add up all these numbers in the numerator to even get to the division. So let's go ahead and do that. And throughout this practice test, you should feel like there's a lot of additional steps in all the problems that really test your ability to do the arithmetic. Again, this is the more challenging practice test that I put out so far. But some of you will probably do pretty well on this one, regardless of the fact that it's pretty hard. So the most important thing to do when you're adding up decimals is to line up your decimal place, because when you add decimals, you just drop it into place, and that's the first thing I like to do. This one's pretty easy, all zeros, so we're just going to put a 0 there. Now this one, again, is fairly easy. 6 plus 3 is 9, plus 1 is 10, so we'll add a 0 there, carry the 1. We have 5 plus 4, which is 9, plus 1 is 10, plus 3 plus 1 is 14. Let me just double check myself. 5 plus 4 is 9, plus 1 is 10, plus 3 is 13, plus 1 is 14. Carry the 1. 4 plus 5 is 9, plus 1 is 10. 7 plus 8 is 15. 10 plus 15 is 25. Carry the 2. 2 plus 1 is 3. So we can see that the numerator adds up to 354, and it's divided by 5. At this point, we can now regard this as long division, namely 354 divided by 5. That looks like this. And again, the way I like to do this problem is, the way I like to do division with these problems is to try to get as close as I can to this whole number without going over. I know 5 goes into 35 7 times, so that means 5 will go into 354 70 times without going over. 5 times 70 will be 350. Let's go ahead and subtract. And you may have noticed that I haven't put a decimal place in yet. I'm going to talk about that in just a second. 354 minus 350 is 4. 5 does not go into 4. It's too big, so I have to add a 0 here. When I add a 0 there, I bring a decimal up there. 5 goes into 40 8 times. 8 times 5 is 40. So we can see there's no remainder. Therefore, we know our average is $70.80, which is this answer choice right there. Again, none of these problems have been easy so far. Alright, number 10. A woman drives west at 60 miles per hour. After an hour, her husband starts to follow her. How fast must he drive to catch up to her 4 hours after he starts? This should say after she starts, not he. So I'll go ahead and fix that in my problem. Again, I do make typos occasionally, so I'll fix that. So a woman starts leaving. Again, we have directions, so let's go ahead and do this real quick. This is north, south, east, and west. Again, we're told she heads west, which is this direction. She's going at a rate of 60 miles per hour, and she's traveling for 4 hours. Again, I gotta fix that. We're told that he leaves an hour after she leaves, which means he only has 3 hours to catch up to her, and that's all we know about him. Okay? In light of that, we have to use the distance formula, namely distance equals rate times time, twice to solve this problem. In this case, we want to find out how far she drives in 4 hours. That way we can find out how far he has to cover in 3 hours. So let's go ahead and plug things in accordingly, just focusing on her information. Again, we're trying to find how far she went. So we're going to leave D as blank. We're told she drove for 4 hours, so that's the rate. Let me start over. We're told that she drove at a rate of 60 miles per hour, so that's R for 4 hours, which is T. 60 times 4 is 240. Okay? So we know in 4 hours she drove 240 miles. He has to catch up to her in 3 hours, so he also has to go 240 miles, albeit in 3 hours. So again, we're going to use the distance equals rate times time formula to figure that out. In this case, we know how far he has to go, namely 240 miles. We know how long he has, namely 3 hours. And we need to find out how fast he has to go to catch up to her in those after 4 hours. or after she's been driving for 4 hours. So we're going to go ahead and solve. We're going to divide both sides by 3. Let's cross this out. 240 divided by 3 is 80. So we can see that he has to drive at a rate of 80 miles per hour in order to catch her after 3 hours if she left an hour ahead of him going at 60 miles an hour. Again, pretty tough problem. One lap on an outdoor track measures 1/4 of a mile around. To run a total of 5.5 miles, how many laps must a person complete? So we know there are 4 laps in a mile. So to go 5 miles, that's going to be 5 times 4, which is 20 laps. To go the final half mile, if each lap's 1/4, we know it's going to take 2 laps to go a half mile, so this is going to be plus 2 laps, which is going to be 22 laps. If you needed me to break this down even further, we have this 1 lap equals 1/4 mile. Therefore, 2 laps equals 1/4 plus 1/4. 1/4 plus 1/4 is a half mile. 3 laps equals 1/4 plus 1/4 plus 1/4, which is 3/4 of a mile. And 4 laps equals 1/4, 1/4, 1/4, just 1 mile. Okay? So this is where we get our 5 times 4, and this is where we get our half mile from. Okay, number 12. A dosage of a certain medication is 13 cc's per 100 pounds. What is the dosage for a patient who weighs 275 pounds? So this is a proportion problem. We have 13 cc's per 100 pounds equals how many cc's per 275 pounds. As you can see, I put cc's on the top here, cc's on the top here, pounds here, and pounds here. Let's go ahead and get rid of those to solve this. This is going to be 13 over 100 equals x times 275. Again, this x is in place of how many cc's per 275 pounds we need. To solve proportions, you cross multiply. That is, you do 100 times x and 275 times 13. Let's go ahead and work out 275 times 13. 5 times 3 is 15, carry the 1. 7 times 3 is 21, plus 2 is 22, carry the 2. 2 times 3 is 6, plus 2 is 8, add a 0. 1 times 5 is 5, 1 times 7 is 7, 1 times 2 is 2, let's add. 0 plus 5 is 5, 5 plus 2 is 7, 8 plus 7 is 15, carry a 1, 1 plus 2 is 3. Okay, so we're left with 100x equals 3,575. Then we have to divide both sides by 100 to get x by itself. Let's cross this out. Again, as I did in an earlier problem, when we have anything divided by something either to 10, 100, 1,000, or so on, we can just shift the decimal place according to the number of zeros that there are and solve this problem mentally. Again, this is 3,575 divided by 100. The decimal's here. There are 2 zeros here. So I'm going to shift it in 1, 2. So this is 35, 75 cc's, which is right there. Again, you could work this out as 3575 divided by 100, but this is a tremendous amount of work. Whenever you're dealing with something that's divided by 10, 100, or 1,000, you have to be able to shift the decimals to save yourself a lot of work and to save yourself from making mistakes. Okay, number 13. During exercise, a person's heart rate should be between 60 and 90% of the difference between 220 and the person's age. According to this guideline, what should a 30-year-old person's maximum heart rate be during exercise? So again, they've given us all the information we need to know to solve this, namely that a person's resting heart rate should be between 60 and 90% of 220 minus their age. So that looks like this. I'm going to put heart rate in the middle. 0.6 is the same as 60%. Again, this is 220 minus the age, which is 30 in this case. And again, we're told it's between 60 and 90%. 0.9 is the same as 90%. And again, this is 220 minus 30. And in this case, what should their absolute maximum heart rate be? We're going to focus on the 90% to solve this one. So let's go ahead and work that out. Let's keep working it out accordingly. 0.9 times 220 minus 30 is 190. So we have 0.9 times 190. That looks like this. Again, we're multiplying a whole number by decimal. Let's move the decimal over one place and add it back in at the end. So we're really doing 190 times 9, albeit with one decimal place to shift back into the left at the end. 0 times 9 is 0. 9 times 9 is 81. Carry the 8. 9 times 9 is 1 plus 8 is 17. Shift our one decimal back in. We can see that this is 171 beats per minute for a maximum heart rate. Okay, another traveling problem. On the same latitude, so they're on the same line. Company A travels east at 14 miles per hour. Company B travels west at 28 miles per hour. If two companies start out 2,100 miles apart, how long will it take them to meet? So we know we're going to be dealing with the distance formula, namely distance equals rate times time. We know that if this is company A and this is company B, they're traveling toward each other, albeit at differing rates. Company A is traveling at 14 miles per hour, whereas company B is traveling at 28 miles per hour. They're going to meet somewhere here in the middle. We're told the total distance they have to travel is 2,100 miles. Okay, so this is a combined rate problem. Whenever you have two objects, trains, convoys of troops, or anything traveling toward each other, you have to view the problem as a combined rate problem. That is, you have to think of these two companies as one. Let's call it company C, traveling the same distance, 2,100 miles, albeit at a combined rate of these two companies, that is 28 plus 14 miles per hour. 8 plus 4 is 12, carry the 1. 2 plus 1 is 3, plus 1 is 4. So company C is traveling the same distance, albeit in one direction at 42 miles per hour, which is a combined rate of company A and company B. This will tell us how long it will take them to meet in the middle. So let's go ahead and plug that into the distance formula. Again, we know the distance, it's 2100. We know the rate in this case is a combined rate of 14 plus 28, which is going to be 42 miles per hour. The only thing we don't know is how long it's going to take them to meet. So in other words, we have to solve for t. To solve for t, we're going to divide both sides by 42. This crosses out. We're left with t equals 2100 divided by 42. Okay? And again, we can regard this as division. 2100 divided by 42 looks like this. Now we have to ask ourselves, how many times does 42 go into 2? It doesn't. It's too big. How many times does 42 go into 21? It doesn't. It's too big. How many times does 42 go into 210? Well, based on these answer choices, I know it's going to be a whole number. So I know 42 is going to go into 210 evenly, and then I'm just going to add a 0 to it. So at this point, I would start using my answer choices to try to solve this problem. Let's multiply this by 50. If this gets us 210, we know we just have to tack a 0 on and be done. 0 times 2 is 0. 4 times 0 is 0. Add a 0 since we're starting this 5. 5 times 2 is 10. Carry the 1. 5 times 4 is 20. Plus 1. Let's add. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus nothing is 1. 2 plus nothing is 2. So we can see 42 goes into 2100 50 times with no remainder because 50 times 42 is 2100. Okay? Okay. 15 says all the rooms in a building are rectangular with 8-foot ceilings. One room is 9 feet wide by 11 feet long. What is the total surface area of the room? So if you take a look at my channel, you'll see I have a video up there in which I discuss the geometric formulas you need to know. One of those formulas is to find the surface area of rectangular prisms. And in that case, you would have to know this formula from memory. It's this: 2 times length times width plus 2 times width times height plus 2 times length times height. Again, this is finding the area of all the faces of the prism and multiplying it by 2. So let's go ahead and plug things in. Let's identify our length, width, and height. Height is going to be 8. The ceilings are 8 feet off the ground. 9 is going to be our width, and our length is going to be 11. So let's go ahead and plug it in. This is 11 times 9 plus 2 width times height. This is 9 times 8 plus 2 length times width. Length times width is 11 times 9. Let's keep working this out. 9 times 11 is 99. 9 times 8 is 72. And 2 times... Oops, I made a mistake here. Width is... This should be 8 right there. The height is 8, not 9. Plus 2. 11 times 8 is 88. Okay. Now we have to multiply all these by 2 and then add them together. So that's going to look like this. 99 times 2. 72 times 2. 88 times 2. Okay. 9 times 2 is 18, carry the 1. 9 times 2 is 18, plus 1 is 19. 2 times 2 is 4. 7 times 2 is 14. 8 times 2 is 16, carry the 1. 8 times 2 is 16, plus 1 is 17. As I said, we have to now add all these together. So this is going to be 198 plus 144 plus 176. So let's go ahead and work that out. 6 plus 4 is 10, plus 8 is 18, carry the 1. 9 plus 1 is 10. 7 plus 4 is 11. 10 plus 11 is 21. Carry the 2. 1 plus 1 plus 1 is 3. Plus 2 is 5. So we can see that this is 518 feet squared, or square feet. Okay, number 16 says a floor plan is drawn to scale so that a 1/4 inch represents 5 feet. If a hall on the plan is 4 inches long, how long will the actual hall be when it's built? So again, this is another proportion problem. This right here is a 1/4 inch per 5 feet, or represents 5 feet. We want to know how long the actual hall is going to be if the plan has the hallway at 4 inches. So again, we want to know how many feet the hallway is going to be. And again, I kept inches in the numerator and feet in the denominator. As I said, when we have proportion problems, we cross multiply. That is, I do 1/4 times x, 5 times 4. And I just put the measurements in there so you can set up your proportion. When you do the math, you actually need to take them out. So it's going to look like this. Now we can cross multiply. 5 times 4 is 20. 1/4 times x is 1/4 x. Now we're solving for x. We're going to get rid of this 1/4, we're going to multiply both sides by 4. This crosses out. We're just left with x there. Again, 1/4 times 4 is just 1. 1 times x is x. 4 times 20 is 80. So we can see that according to this proportion we set up, if 1/4 inch represents 5 feet, 4 inches is going to represent 80 feet. Okay? One more problem. Oh, that was the last problem. So that's all I had for you for this video. Again, as I stressed 3 or 4 times now, these problems, apart from a few of them, are pretty challenging. In addition to being challenging, I set them up so they required more than just one step to solve. For example, many of the problems required you to do addition with decimals or long division several times before you could get to the answer choice. If you're doing really well on the ASVAB, you'll start to experience that, which is a very good sign that you're doing well. That said, if you liked this video or found it helpful, feel free to give it a thumbs up. If you think my content's helpful, including this hard video, feel free to subscribe to my channel. But on that note, I'm going to go ahead and cut you guys loose.
Konnichiwa.